Hi everybody, here we'll be looking at a very interesting chapter, which are these other worlds here, the moons of the Jovian planets. So we'll be starting with the Galilean moons, which are Jupiter's moons. We'll be looking at Io and its volcanoes. We'll be looking at tidal forces. We'll be looking at Titan and its atmosphere. Also, we'll be looking at lakes on Titan. We'll also be looking at Europa, Enceladus, and Triton. We'll be looking at some of their magnetic fields. And specifically for Europa and Enceladus, we'll be looking at possibilities for life. And we'll be finishing with Pluto. First though, we're going to review this graph that we looked at before when we were looking at the Jovian planets. That shows you, as distance increases from the sun, how the temperature changes. So earlier, recall that the terrestrial planets, they're near the sun, so it's hotter here, and they tend to be rocky. And the Jovian planets, they're in a region away from the sun where it's so cold that everything is, the average temperature is below the freezing temperature of water. So here, the role of ice, the role of rocks, is replaced by ice. So we'll find that whatever plate tectonics you observed on the terrestrial bodies, you'll observe similar tectonics, but now with ice instead of with rocks. And this graph here shows you, we talked about the Jovians, but here if you look at it, now we're going to be looking at the moons. And overall, the Saturn and Jupiter's moons, they receive about the same amount of heat from the sun. And also we'll be looking at Pluto. Pluto receives about the same amount of heat from the sun as Neptune does. So we'll be looking at these icy worlds here. In the cold parts of the solar system. So here again, this is to kind of give you an idea of why it's so cold here. So first you see these are the terrestrial planets, these are the hot regions, and Jupiter and all the Jovians, they're extremely far away from the sun. And for example, if this is how big the sun looks like to us on Earth, this is how big the sun looks like if you're orbiting near Jupiter, all the way down to Neptune and Pluto. It's just a dot in the sky. So they receive less heat, but we're going to see that these moons, they're very active. And we'll try to understand how are they so active when they're not receiving as much heat from the sun as we do. So the first moon that we're going to talk about is Io, but actually let's look at the Galileans first, and then we'll go specifically into the Galilean moons. So the Galilean moons are in order from Jupiter. This is from Jupiter, you have Jupiter here. So the closest moon is going to be Io. The next closest is going to be Europa. After that is going to be Ganymede, which is the largest moon in the solar system. And then you have Callisto. So here we have a picture of Europa. And this is a picture of Io. And Europa is actually an easy moon to identify because you can see right here it has a nice smooth surface. And you can see it with the casting a shadow onto Jupiter. So these are the moons that Galileo was able to see using a telescope. So the first moon that we're going to concentrate on is going to be Io. So Io is the moon that orbits, is the Galilean moon that orbits closest to Jupiter And here also, this is an easy recognizable moon. It has a lot of pock marks, but if you look at it, very few craters. So what are all these pock marks? I mean, this looks like smoke here rising above. So let's see what all of that is. So by observing Jupiter, observing Io from space, you find that the property that stands out the most for Io, so this is one of Jupiter's moons, is that it's the most volcanically active body in the solar system. And its surface is covered with lava. So it had the reason why you don't see a lot of craters is because lava is constantly flowing onto the surface. So what you're looking at here, if you zoom out, it's actually a volcano, and what you're seeing are the plumes from the volcano. So that's looking at it face on, and you can also even look at it from the side. So from the side, this is an actual picture here of these volcanic plumes, and this is a computer simulation of what those plumes look like. So Io is covered with volcanoes, and lava is constantly flowing onto the surface, and that tends to cover up any craters and smooth out the surface. So Io has a smooth surface because a smooth lava covered surface. And the other distinguishing feature, it has this yellowish color because there's a lot of sulfur being ejected. So this is, I mentioned that these moons live in a cold part of the solar system. So out here it's actually very, very cold, below freezing. So how is it that Io can be the most volcanically active body in the solar system when it's in one of the colder regions? So that's what we're going to try to understand next. The cause of Io's volcanic activity is related is something that we talked about before in terms of the moon and the Earth. So when Io orbits Jupiter, what it feels is that the side closer to Jupiter feels more force, and the side of Io farther from Jupiter feels less force. And because of that, as Io orbits around, it gets warped and stretched. So if you look at it, in this part of the orbit has a spherical shape, and on this part of the orbit, it's more oblong. So over here. And then it goes from, and you can see that the shape changes as Io orbits. So this warping of the shape of Io, what it does is that it heats up the internal parts of Io, and that releases heat. And that heat is able to melt the rocks in its mantle, and that's able to create all the volcanic activity, despite the fact that in these regions here, you have temperatures that are below the freezing temperature or below freezing. So this effect of different forces acting on different parts of Io, those are the tidal forces. And so these tidal forces come from the combined gravity of Jupiter, and also it's another moon nearby called Europa that we'll be looking at next. So the tidal forces from Jupiter and also Europa warp and stretch Io, and this melts the rocks, and that causes Io to be, even though it's in a cold part of the solar system, to have the most volcanic activity. So if you look at the inner structure of Io, it has an iron core and a rocky mantle, and that warping and stretching heats up the rocky mantle, and that generates all the volcanic activity.